Okay, I want to talk about computing the total amount of magnetic flux, phi. So suppose you have a surface. That surface, in this case, let's consider it to be the Earth, right? So you have a latitude and longitude, right? We'll call it X and Y here, just to keep it simple. And you want to plot this, and the value we want to plot here is along the z-axis, actually the total amount of magnetic flux, total magnetic flux. So suppose you have a power line, and that power line, goes like this. If we were to plot the amount of magnetic flux of that power line, it would probably look something. It would form a surface that would look something probably like this. Right? It would kind of go like that, and then the highest value would be directly adjacent to the power line, and then it would sort of drop off. And I hope you can kind of see the ugly 3D drawing I'm doing here, but it would kind of drop off like this. The curve, these curves may not be perfect, but you get the point. It's going to sort of drop off in sort of like asymptotic curtain. I don't know whatever you want to describe it. And so this is going to be magnetic. This is going to be the amount of magnetic flux, right? And maybe there's a function, this is a functional form because we're using AC, but you get the point. So now let's talk about, you have a pipeline, and a pipeline goes, say, like, let's say the pipeline, so the pipeline's going to be kind of underneath, right? So the pipeline's going to go, let's say it goes like this, right? Could be parallel or adjacent or whatever. To compute the total amount of magnetic flux for that pipeline, and again, correct me if I'm doing this wrong, is essentially computing the surface integral of the pipeline, surface integral of the pipeline over this surface, right? So like that surface integral is going to kind of look like that. I don't know, this drawing is not the greatest, but you can see as it's getting away, it's getting smaller, and as it's getting closer, the magnetic flux is higher. So like you're going to compute the sum of this as essentially the sum or the surface integral over this space as the total amount of magnetic flux. So I don't know, phi B for that is going to be the total amount of magnetic flux over this particular pipeline, and then we're going to sum that over sort of all of the available pipelines. I don't know, P whatever to Pn, because there might be another direction or something, but we're going to sum it up over all of them. This is obviously very simplistic. This doesn't count for phases or circuits or whatever, but at least I think this might be a start. Please tell me this is smiley face or sad face.